What can one piece of porcelain tell us about the American Revolution? In this film, I will recreate an American porcelain masterwork known as a Bonnin and Morris pickle stand. The elaborate shell dishes were produced at the American China Manufactory, established in Philadelphia between 1770 and 1772. Its founders, Goose Bonnin and George Anthony Morris, succeeded in the first American manufacture of sophisticated porcelain. In the 18th century, British and European porcelain shell stands were used in elaborate dining rituals to serve pickled delicacies known as sweetmeats. In 1770, Philadelphia was the center of colonial America's economy. Domestic ceramics manufactories took hold throughout the revolutionary city, supporting the cause of both economic and political independence. Philadelphia porcelain rivaled the wares of Britain and Europe in a city burgeoning with forces of revolution. The Philadelphia-made pickle stand has three major components: the large scallop shell dishes, a column-like stem, and a lobed top cup. The most significant discovery that distinguishes the 18th century American design from its British and European counterparts is that the large shell dishes are cast directly from a natural scallop shell. Pecten Maximus, known today as an Irish baking shell, is a specimen that matched the depth, width, and number of lobes of the 18th century American shell dishes. Noticing the detailed surface of ridges and growth rings on the Bonnin and Morris examples was the diagnostic evidence that revealed the shells were life cast and not modeled. To make the plaster mold, the natural shell is placed in a thick-walled clay form, and a mixture of plaster is slowly poured over the shell and filled to the top. After the plaster cures, the clay walls of the casting vessel are peeled away and the scallop shell is removed from the mold. The plaster cast captures the intricate surface of the natural shell as a crisp negative impression. Once the mold is dry, it's ready for slip casting. The porcelain slip is gradually poured into the mold and filled completely up to the edge. The thickness of the cast porcelain is determined by the length of time the slip remains in the mold. The excess is carefully poured away, leaving an even layer of thickened slip that adheres to the mold's surface, following the undulating contours of the shell. The clay coil provides a barrier while pouring off the excess slip. The coil is removed, leaving a clean line at the back of the shell casting, and the cast shell is left to cure in the mold. In addition to the large shell mold, molds for the stem and the top cup are cast in plaster. The porcelain cast for the three major components of the pickle stand are now at the leather hard stage and ready to remove from the plaster molds. The two-piece mold for the stem leaves seams that will be removed before constructing the piece. The distinctive top cup of the American original has 32 scallop lobes that taper from the top to the base, recreated here. When the large shell casts are removed from the mold, the porcelain captures the intricate ridges and growth rings of a life-cast natural shell. To make the press molds for the smallest shells, a slab of thick porcelain is formed. A variety of small natural shells are lightly greased to prevent them from sticking. The shell is firmly pushed into the soft clay and immediately removed, leaving a crisp impression. Each sprig mold has a mosaic of shell imprints. The clay press molds have to dry and be bisque-fired to a low temperature before they're ready to use. I use my thumb to press a soft porcelain ball into the mold. The porous nature of the bisque mold releases from the clay so the shell cast can be removed right away. The tiny shell molds are filled with bits of porcelain and removed with a needle tool. The process of recreation revealed that there are over 75 elements in this small piece. All of the parts of the pickle stand, whether slip cast, press molded, or hand formed, must be kept at a leather-hard consistency up to and during its construction. The assembly begins with the orientation of the 3 large slip-cast scallop shells turned face side down. The ears are cut away, and the shells are closely fitted together to form the base. Slip is applied lightly along the sides of the shell seams. A length of porcelain is rolled out and stretched into a coil. Using a damp sponge, I run the coil between my thumb and forefinger to create a triangular shape. The triangular clay strip is wedged into the seams between the shells to connect them. I use my finger and then a series of tools to pounce in the clay and stipple the surface. This technique reinforces the structure while creating a design that simulates fossil coral. Once connected, the tripartite shells have been carefully turned right side up to continue construction. Slip is applied to the flanged base of the molded stem and to the seams of the shell base to adhere the stem to the base. The stem is seated at the center of the 3 shells and connected. Slip is then applied to the top of the stem, and the top cup is moved into place and lightly compressed into the stem. A strand of seaweed is represented by a thin, flattened coil of clay that wraps around the base of the stem and spirals to the top. This serves to conceal and reinforce the joins of the stem to the top cup and provides a point of attachment for the tiny snail-like shells as they ascend the column. The pickle stand is ready for the attachment of the small shells. Using the original as a guide, I begin to compose clusters of cockle shells and tube worms along the seams and up to the base of the stem, secured with drops of thick slip. The coral-like texture is both visually rich and structurally significant, providing a variegated surface to bond the fragile shells to the stem. The tiniest shells are applied to the spiral of seaweed. Tube worms are formed by rolling a small coil of clay between my fingers and scooping out the ends with a tool. The placement of the tube worms on the stem are marked by using images of the original. The design elements on the stem create movement that travels both up and around the form to the pinnacle. The final stage in the assembly is the attachment of the cone-shaped feet. The stand has to be turned upside down for this final step. A plug of clay is rolled to a point. The pointed end is pushed firmly into the deep cone-shaped mold to ensure the clay reaches the tip. A damp bit of clay helps to pull the foot out of the mold, and the feet are set aside to become firm. The feet are positioned on the underside of the shell dishes and marked with a needle tool. The surfaces are scored and a thick slip is applied. Gently supporting the shell from the underside, the foot is pressed to the shell form and the excess slip is wiped away. Finally, the dish in an extremely fragile raw state must be picked up and turned over to rest on the elegant conical feet. The dish is carefully supported from the underside and interior, avoiding putting any pressure on the delicate relief. A decorating slip formula includes metallic oxides of cobalt, copper, and iron. The slip is hand-painted on the bisque-fired pickle stand. The edges of the shell dishes and the shell relief are painted with a series of fine brush strokes. The cobalt slip quickly absorbs into the bisque clay, and the brush needs to be frequently refreshed with pigment. The piece I created at the Museum of the American Revolution was transported back to my Virginia studio and bisque-fired in order to decorate with an ornate floral pattern. More complex patterns are marked in pencil before hand painting in the cobalt pigment. 3 of the 7 known examples of the Bonnin and Morris pickle stands have similar imagery of bugs and flowers. Each piece is entirely unique, just as no 2 of the 18th century examples are alike. A second bisque firing is required to harden the cobalt slip and prevent the decoration from running when the piece is immersed in the glaze. The piece is rinsed before glazing, which removes any loose debris and dampens the bisque so the glaze will not absorb too quickly and can flow into all the crevices of the relief. Dry chemicals of feldspar, ball clay, and frit are weighed out in proportion. Trace amounts of cobalt and copper sulfate are added to the glaze formula for a slightly blue tint once fired. The glaze is mixed with water and run through a fine sieve to thoroughly combine the materials. The pickle stand is immersed and rotated in the liquid glaze, coating all the surfaces. The bisque clay absorbs the water from the glaze within seconds. A A dry, opaque coating of raw glaze temporarily covers the decoration. The final glaze firing reaches almost 2200 degrees Fahrenheit. Pyrometric cones that indicate temperature are viewed through the kiln's spy hole. The glaze melts or fluxes into a transparent glassy surface. Because the American design is cast from a natural scallop shell, its broad open form is prone to warp or even collapse in the glaze firing. During this film project, I noticed a series of small, regular teeth marks around the feet of the 18th century originals. I decided to experiment with how they may have been supported in the kiln. I made porcelain kiln furniture to recreate the placement and markings I noticed. I also used a natural shell to support the dish at its center. Though the shell maintains its shape, it's actually sintered and easily breaks away from the glazed surface after firing. The bisque porcelain stilts shrink at the same rate as the dishes and support the shells without impeding the movement from shrinkage during firing. Even with the help of modern ceramic fiber, experimenting with the support of the stands was a high risk to the pieces emerging successfully from the kiln. My practice of recreation is to discover the secrets held within the form of this unique American artifact. And through the art of making, bring to life its relevance in the 21st century.